Today we are going to practice simplifying radicals. A radical is in simplest form if there's no fractions left under the radical, there's no perfect power factors in the radicand, and there's no exponents in the radicand greater than the index. I will explain that third bullet when we actually get to one of those problems. Finally, radicals are not allowed to be in the denominator of a fraction. If that is the case, we have to end up rationalizing, which I will show you on another day. So for practice, the first one we have is the square root of 25. Most of you already know that it's 5, but I'm going to show you how it's 5 so when we do the other problems you can see how they work as well. What you end up doing is you break down 25 into its factors. And 25 breaks down to 5 and 5. 5 doesn't break down any further, so what you do from there is you circle up your pairs, meaning I have two 5s. Any pairs will come outside of the radical, so you have a 5. And you have nothing else inside no other factors left, so it's just a 5. For example, with the next one, if we look at 98c to the 4th power, if I want to break down 98, I could see that it is 49 and 2. 49 further breaks down to 7 and 7. I can't break down anything else, so I circle up my pairs. I have a pair of 7s. So 7 is going to go on the outside of my radical. I have a 2 left over, so inside my radical, I need to write a 2. For the c to the 4th power, that means you have 4 c's. Circle up your pairs of c's. You have 2 pairs of c's, so on the outside you need to show you have 2 pairs of c's. The way you show that is c squared. So 7c squared radical 2 is your answer there. For the next one, 5 radical 200xy. We need to break 200 down. 200 breaks down to 20 and 10. 20 breaks down to 5 and 2. 10 breaks down, 10 breaks down to 5 and 2. 20 breaks down to 10 and 2. 10 will break down to 5 and 2. From there we circle up our pairs. I have a pair of 2s. I also have a pair of 5s. I have the 5 here and the 5 there. They can come from different branches. And so, pair of 5s, pair of 2s come out by multiplication. 5 times 2 is 10. Times the 5 on the outside already is 50. Inside the radical, you have an extra 2 left over. For the x's, you only have one x, so you have no pairs, so that goes underneath the radical. For the y squared, that's like y times y, so you have 2 y's. And you can circle up pairs, so you'll have 1 pair of y's on the outside. The next one's a little bit different because notice the little 3 on the outside. That means cubed root. Instead of circling up pairs, we're going to circle up sets of 3. For example, 24. That breaks down to 6 and 4. 4 breaks down to 2 and 2. 6 breaks down to 3 and 2. So instead of circling up pairs, the little 3 tells me circle up sets of 3 instead. So I have 3 2s. That means now I'm going to have a 2 on the outside. And instead of writing a square root, I got to write a little third root. So I'm going to write that little 3 again. And then I am left with a 3. So that goes underneath the radical. Next one, radical 4a over 25. Everyone, hopefully you know the square root of 4 is a 2. And the square root of 25 is a 5. So 2/5 will be on the outside. And then for underneath the radical, you have an a. You only have one a, so that needs to stay underneath the radical so you don't have pairs there. For 128x squared, 128x squared breaks down to 16 and 8. 16 breaks down to 4 and 4, 2 and 2, 2 and 2. 8 breaks down to 4 and 2, and then 4 breaks down to 2 and 2. Circle up pairs, you got 1, 2, 3 pairs of 2's. So it comes out through multiplication. 2 times 2 is 4, times 2 is 8. X squared, you have 1 pairs of x's. And then you have one extra 2 left over and no extra x's. So underneath the radical is radical 2. 3 more ones here. We have 50a cubed b to the 5th. So let's break down 50. 50 breaks down to 25 and 2. 25 breaks down to 5 and 5. Pair of 5 circle up. A cubed is like 3 a's. You have 1 pair of a's. And b to the 5th is 5 b's. You have 2 pairs of b's. So it comes out as b squared for 2 pairs. Underneath the radical, you are left with a 2, an a, and a b. For 54, y to the 8th. Again, it's the cubed root again, so that means we're going to take out sets of 3 instead of pairs of 2. 54 breaks down to 9 and 6. 6 breaks down to 3 and 2. 9 breaks down to 3 and 3. So I'm circling up my 3 3's. My y to the 8th is like 8 y's listed out. So imagine 8 y's listed out. You will have 2 pairs of y's. So on the outside of the radical, we are going to have 3y squared, cubed root, and we have a 2 left over, so 2, and then you have 2 y's left over, so y squared. Notice the root, the 3, is larger than the squared, the 2 y's in there, so that's allowed to happen. That's okay. And let's look at our last one here. Let me move this over a little bit so I have some room. This is a 4th root instead, so you can only take out something if it has 4 of them. Now 2 doesn't break down, but a to the 8th power does. You have 8 a's lined up. You have 2 sets of 4 a's. So on the outside of the radical, you can put an a squared because you have 2 sets. Nothing else can come out because you only have 2 b's and 3 c's and only have that 2 in the 1. So inside the radical, you still have a 2 in the numerator. In the denominator, you still have b squared. And you still have c cubed. And it's the 4th root out there. Now, one of our rules did say that you can't have a fraction under the radical. In the future, I will show you how to further simplify it, but for today, we're going to stop at that piece right there. And then we have one word problem. The lengths of the legs of a right triangle are 8 and 12. So let's draw our triangle. See if I have a triangle in here. No. Okay, so we have 8 and 12. Express the length of the hypotenuse in simplest radical form. Hopefully you know to use Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. A and b are your 2 sides, so 8 squared plus 12 squared equals c squared. That's 64 and 144, which is 208, equals c squared. You gotta take the square root to solve for c. Square root of 208. 208 breaks down to 16 and 13. 16 breaks down to 4 and 4. 2 and 2, 2 and 2. So you have 2 pairs of 2's can come out as a 4. It's 2 times 2. Radical, and you have a 13 left over. That's your final answer there. And why don't you guys work on the do now right now?